Hello.
Yes, sir.
Okay. So, uh, is there anything you want me to discuss from week 5? Any specific doubt or maybe any conceptual doubt? So, have you started week 5 or you guys are still with week 4?
Yes,
I
sir. I
began
have
it yesterday, sir.
Yeah, yesterday I guess Vicky took a session, so I guess he discussed almost all the concept of week 5. So, have you started solving questions of week 5?
not yet, sir.
Okay, you are still with week 4.
No, week 4 I have completed yesterday only.
Okay.
Sir, wanted to ask one question.
Hmm.
Uh, because in qualifiers we will have from week 1 to week 4.
Hmm.
So it is necessary to complete week 5.
Okay, certainly you don't have to complete it for qualifier. Okay, but again, but certainly you need to study all these things for week quiz 2. So so if you are not going to complete it within the given period of time, then probably in for quiz 2 you have to put some extra effort. Okay. So otherwise
But
you may not. Hmm.
but sir, we will not be having enough time to prepare that
For what?
for qualifiers.
No, no. So it's up to you. Like if you want to start week 5, it's up to you. You can start uh, before sorry after qualifier. But again, like if you want to complete, then again you will be in trouble before quiz 2.
Okay,
Uh,
so
eh, so
the
it's
quiz is when, sir? Quiz is when?
quiz 2. I'm
No,
not.
it is when?
Maybe it's after week 9, I guess. Mhm.
Okay.
So again, during that time you have to cover a lot of things. So it's up to you. Like if you can cover all these things with the given period of time, then probably you don't have to. Otherwise, uh, it's better to start. So it's better to cover few concept of week 5 before qualifying. Okay.
Okay.
Again, certainly we are not going to ask you any question from week 5 in qualifying.
Okay. And sir, this class is meant for conceptual clarification or to solving the doubts.
Yeah, you can ask anything. Yeah.
Okay.
Okay, maybe I guess since you are not asking anything, let me take some question and solve it. Some activity questions of week 5. Since Vicky almost covered all the things, so let me take few questions and solve it. And also, I guess this will be helpful for you for the qualifier also.
Sir, we can ask from anywhere also, no? It is not to for only week 5 only.
Certainly, this thing is for week 5. Again, you can ask anything, like from
Okay, sir.
any of
Thank you.
those. Okay, so the thing is, okay, let me solve few questions. Okay, I will take, let me solve 1, 2, 3 question. If you have a doubt from some different weeks also, you can ask. But before that, let me solve few questions. Okay, so suppose you have a function. Okay, so suppose, so basically you have bunch of functions, and you, not function, in some sense you have some expression. Okay, you need to tell which of the following are basically functions. Okay. So this is one expression, and this is plus or minus uh, x plus 1, and the third one is x squared plus 4x plus 3. Okay, and the last one is f of x equal to 100. So the question is, which of the following are functions? Okay, so the question is, which of the following, so you have four expressions, so which of the following are functions? Functions from 0 comma, let's say 0 comma infinity to, let's say r. Any idea which of the following are functions?
The first one and the last one.
So you are saying the first one uh, and the last one. Okay, so certainly the first one is a function, because so function basically says what, like for for each x you have a, for each x you have only one output. Okay, for each x you have only one output. So certainly if I'll take some x. Okay, if I take some x, then the output is basically what? So the output is 4x plus 3. So the output is unique for each x, the output is unique. So that's why the first one is, certainly it's a function. Okay, so what about the second one?
So it's kind of right-handed parabola and vertical line test it fails.
Yeah, so okay, so you don't have to go to these things. So from directly from the definition, basically you can say that this is not a function,
We have
because
two outputs for
yeah, so if you take x, then basically you have two output, that is plus or minus x plus 1, right? So for example, if I take 1 x to be 1, then basically what I'm getting plus or minus square root of 2. So if I see, so this is my domain and this is my codomain. So as you can see, so 1 basically goes to uh, root 2, and 1 as well as it goes to minus of square root of 2, right? So for a single element in the domain I have two output. So this condition is not allowed for a function. Okay, so that means this second option, this is certainly, it's not a function, right? So what about the third option? Whether the third option is a function or not?
sir, in the given range it is a function. I was mistaken.
Yeah, so if you see, actually for each x, so each x you have only one output, right? So for each x you have only one output, that is basically x square plus 4x plus 3. So if I take x to be 1, then basically what I will get? I will get 1 plus 4 plus 3, which is 8. Okay, so you can see for each x I have only one output, one f of x, that is x square plus 4x plus 3. So this certainly satisfies the condition of function. So that means this third option is also a function. Okay. And what about the fourth one? What about the fourth one? Whether fourth one is a function or not?
Sir, but
Sir, it is a function, constant function.
Yeah, correct. For if I take x, so if I take if my input is x, then my output is 400. So for my input there is only one output. Okay, for each input I have one output. But if you see in the case of second function, if I take for each input, okay, for my input I have two output. Okay, I have two output. That's why the second option is not a function. And there are basically there are methods which you can use. That is basically vertical line test. If you draw the graph, so if you draw the graph, then from this graph itself you can also say that whether this is a function or not. Suppose you have a graph like this. So suppose you have a graph like this. Suppose this is a graph of something. So if you use the vertical line test, okay, so if you use the vertical line test, that means this is, let's say this is a point A. Okay, so let's say this is a point A, and so as you can see for A, I have two output. Okay, so this is a output. So this is also another output. Let's say this is A comma, let's say B, and this is A comma C. Okay, so that means in the domain I have something A, and this A maps to B, and A maps to B, as well as A maps to C. So this is not allowed for a function. So for a single output I should get a single input, but in this case for the single output A, I am getting single input A, I am getting two outputs, that is B and C. So if you can use vertical line test to tell whether a given expression is a function or not. Okay, so let me do few more problems related to one and one related to oneness of a function. Okay, so you have bunch of function, and you need to tell which of the following. So you have bunch of function from R to R, and you need to tell which of the following are not 1. Okay, so the first one is, let's say the first one is f of x equal to x plus 1 modulus, okay, minus 20. And the second one is f of x equal to x squared plus 4x. Okay, so the third one is f of x equal to x cube plus 15. Okay, and the fourth one is f of x equal to x3 minus 5x squared plus 2x plus 8. So okay, so let's start with option number 1. So my first question is whether option 1, so this function, whether this function is a 1 function or not. Whether this function is a 1 function or not. Any idea?
No, sir, it is not.
It is not a 1 function. Why?
Uh, because the graph is a V-shaped graph and horizontal, it fails the horizontal line test. Secondly, if we will break the mod, we will get x plus 1 minus 20 as the first equation and minus x minus 1 minus 20 as the second equation.
Yeah, so
So for,
whatever you are saying is certainly it's correct, but okay, so so again, like you don't have to go to all this complicated thing. You just simply you can give two outputs to distinct, sorry, you can give two distinct input for which the output are basically same. So if for two distinct input you are getting the same output, that means the function cannot be one, right?
Yes, sir.
So can you tell me such inputs?
Sir, we can give x is equal to -1 and x is equal to 1.
So
No.
If I give 0 and 1, then output is different.
0 minus 2.
if you are taking x equal to 0,
Yes.
then what is f of x, f of 0? Can you tell me?
F of 0 will be minus 19.
-19.
And what about f of 1? If you take x equal to 1,
Then 2, yeah, 18, minus 18.
minus 18, then certainly it's not a contradiction, right? For distinct input you are getting distinct output.
Oh,
Okay.
so this is 1,
X
1.
is equal to -2.
No, so the thing is for 1 you have to show it for all the possible distinct output. So here what you are doing, you are basically taking two specific distinct input. So you are taking x equal to 0 and x equal to 1. You don't know what will happen if you take x equal to 0, okay, and x equal to minus 2. Okay, that you don't know. So if you take these two value, you don't know what is the input. You only know that for these two input, the output are different. Okay,
Yes.
but you don't know what will happen if you take this x equal to 0 and x equal to minus. So you have to make sure that for all possible two distinct input, the outputs are distinct. Okay, that is what you need to check. Okay, so when you are just, so when you are saying that x equal to 0 and x equal to 1, you are basically you are choosing two specific input, but you have to make sure that for all possible distinct input, okay, your outputs are distinct. Is it clear?
Yes, sir.
So okay, so can you tell me, so again, like if you take x equal to 0, what I am getting? F of 0 is what?
Minus 19.
Minus 19, right? And
Yes.
what about now f of minus 2?
Yes, same.
Hello, am I audible?
-19.
Minus
Minus
19, right? So
Yes.
so from now you can see I have two distinct input for which the output are basically same, right? So I have 0 and I have minus 2, and certainly 0 and minus 2 are distinct. Okay, they are not same, but they are, so but the image of both the elements are same, right? They both of them map to minus 19, right? So that means this function, this function is not 1, right? Because I have to, okay, I'm getting some echo. So as you can see, for two distinct input, I have the same output. Okay, so in that case, not 1. So as you can see, you can actually you can produce lot of this type of inputs. Okay, you can produce lot of this type of input. For example, if you take x equal to 1 and x equal to minus 3, then both of them will have same output. Okay, you can check. So okay, so the next thing is option 2. So what about option 2? Is it a
Not.
1?
Not.
It is not 1. Why?
Because it has two roots. At 0 and -4, it will give 0.
So okay, so the second option is f of x equal to x square plus 4x, right? So this I can write, this certainly I can write x into x plus 4, right? And as you can see, this, as someone already said, this particular polynomial has two roots. Okay, one is x equal to 0 and one is x equal to -4. So that means f of 0 is 0 and as well as f of -4 is also 0. That means I have 0 here and I have -4 here, and both of them are distinct and both of them maps to the same element. Okay, both of them maps to 0. So I have two distinct input and image of both the inputs are same. That means the second option, this is not 1 1. This is not 1 1. And one more thing you can say. So if you see, this is a quadratic equation, right? So this is a parabola. So if you say x square plus 4x, so this is something like of this form, right? Ax square plus bx plus c. So this is a parabola. So now if I, and you know here the coefficient of x square, it's 1, which is positive. So here the coefficient of x square is positive. That means this parabola is opening
Open
upward.
upward.
Yeah. So now if you draw the graph, so the graph will look like this, right? So the graph, maybe it will look like this, right? So now if you apply this horizontal line test, okay, so if you apply this horizontal line test, let's say you draw this horizontal line, if you draw this horizontal line, this line, as you can see, this point, let's say this is x1, and this point is x2. So as you can see, this y coordinate of this point and y coordinate of this point, they are basically same. That means the image of x1 and image of x2, they are basically same. Okay. So image of x1 and image of x2, they are basically same. And certainly x1 and x2, they are distinct. Okay, they are different, but the image of x1 and x2 are same. So that again, this is the another way of saying that this function, this particularly, like if you have a parabola, okay, so it doesn't matter, again, like you can use the same trick if the parabola is opening downward also, right? So you can apply the same trick. Okay. So if you can apply the same trick, if a parabola is opening downward, you can take this line, okay, and this horizontal line test, you can say, okay, you can easily see that at this point, let's say this is x1, and at this point x2, they are different, but the images are same. Okay, so in particular, you can say that a parabola cannot be 1 1 function. Okay, it's certainly it can't be 1 1 function. Okay, so the next one is question option number 3. So this is not 1. What about option number 3?
Yes.
It is 1 1.
Why?
From
Every
the
input
same
will
logic,
give different output.
and
Because it is x is having power of 3.
for every input we have different output.
Yeah, so
It is a
okay,
1-1 function.
yeah. So more or less you are giving in sort of correct answer, but I want a proper proof of this fact, like that why this is
In terms of graph,
uh, yeah. So even it's fine if you can do it in terms of graph also. This is fine. Yeah. So what will be the graph of this function? So So this is
positive. The y it also tends to positive infinity. When x tends to negative infinity, y also tends to negative infinity.
correct. So the graph of xq. So basically what you are doing is, so if you see, you are actually shifting this xq by 15, right? This is what you are doing, right? So if you know the graph of basically xq, then you can easily draw the graph of this function xq plus 1. So you just need to shift that graph of xq by 15 units, okay, upward. Okay, so the graph of xq is more or less like this. So this is the graph of xq. Okay, so you just need to shift this curve some by 15 units. Okay. So okay, so if you shift it will look, like this. So probably it will. So this is 0, 15. And again, like if you do this horizontal line test over this graph, okay, if you do the horizontal line test, if you take any horizontal line, okay, as you can see, this line intersect the graph at exactly 1 point, right? So it can't intersect the graph at more than any horizontal line cannot intersect the graph at more than 1 point. Okay, so that means, so using that test you can say that this function is a 1 1 function. Is it clear why this is a 1 1 function?
Yes, sir.
Yes, sir.
Yeah. So, and in some sense, okay, so
Sir, can you explain it again?
as you can see, so which part is not clear to you? Like, so as you can, so the graph part is clear, right? This is the graph. Hello.
Okay. Yes,
So,
yes.
so the graph part is clear, right? So,
No,
so
sir.
the next, sorry?
No, sir.
No, so do you know this is the graph of xq? This is the graph of xq.
Yes, sir.
So then, as I said, like, so basically, this, if this is the graph of xq, okay. So this is the graph of xq, and so you just need to draw the graph of xq plus 15. So basically, this is what. So if you see this function, so what actually you are doing? So you are adding 15 to this xq, right? So that means you just need to shift this graph of xq. So you just need to shift this graph of xq by 15 units. Okay, upward,
Yes, sir.
certainly upward, because you are adding plus 15. Okay, so that is what I have done here. I have just shifted this graph of xq 15 units upward. So once I have the graph of this function, so this is the graph of this function, then I simply use the horizontal line test. And horizontal lines test says, if you draw any horizontal line, if it intersect the graph at most 1 point, then the function is 1 1, right? And as you can see, if I draw any horizontal line, okay, it intersect the graph at exactly 1 point. Okay, so that means according to the horizontal line test, this function is 1 1. Okay.
Yes, sir. Yes, sir.
And another way of saying is, in some sense, you can see that this function f of so this uh, so so in another way of proving this thing is that, so if f of x is equals to f of y, if this implies that x equal to y, so this is another way of saying that f is a 1 1 function, right? This is another way of saying that f is 1. if this hold, if the image are same and that implies the input are also same, then that means the function is 1. So this is also another way of saying that a function is 1. So now if I take f of x, so f of x is x cube plus 15, right? And f of y is what? Y cube plus 15, right? So that means I can cancel 15 on the both of the side, and finally what I am, x cube equal to y cube. And I know if the cube of two numbers are same, that means both the numbers are same. So basically what I proved here, so I proved here that if the image of two elements, they are same, right? That means my inputs are same. So that means this function is 1. Okay. So this is another way of saying that this function is 1. Okay, so let's go back to the fourth option. So what about the fourth option? Is it 1? Okay, I guess I missed something. So this is not the complete question. So probably this is x cube.
Yeah. Because if it is only x square, it is quadratic, and the quadratic we know it is not a one-to-one.
Yeah. Correct. So what about this fourth one? Whether so this is 1. So what about the fourth one?
So can we say that the degree of this polynomial is even? So this is
This
not
is
1-to-1.
This is not even. This is odd.
But we have x no, so like 3
X
plus 3
cube.
is 5
X
and
x cube.
x
You have
cube.
this is x cube. This is x cube.
Oh,
Yeah.
so it is odd, so we can say it is 1-to-1.
No. That is not true in general. So if the degree is odd, then certainly like you can't say that this is always 1. Okay. Any idea?
We have to find the roots first.
Correct. So first you should try to find the roots of
X
the
is equal to
equation.
-1 is a root.
Equal to -1.
Yeah. So let me write the question properly. So this is my function f of x, which is x cube, right? So this is x cube minus 5x square plus 2x plus 8. X cube minus 5x square plus 2x plus 8. Okay. So someone said that the root is basically what? X equal to 1, sorry, not all the roots,
-1.
certainly one of the root is -1, right?
2 and 4, -1, 2, 4.
So that means x plus 1 is a factor, right? Is a factor. So basically why I have written that x plus 1 is a factor, because I want to factorize this polynomial. I want to know all the roots. Okay, I guess someone already said other two roots, right? So is there any other root of this equation that you know? So certainly -1 is a root. Any other root?
2 and 4.
You are saying 2 and 4.
Yes.
So this is 2q 8 minus 20, yeah, plus 4 plus 8, yeah, 2 is a root, and 64 this is 16 into 5, I guess 80 plus 8 plus 8 16, yeah. So So, okay, so now we know all the roots. Okay. So again, like you can, so after one guess also you can find the roots by dividing this polynomial with x plus 1, or otherwise you can find all the roots by hit and trial method. Okay, so this polynomial I can write it as x minus 2 into x minus 4 times x plus 1, right? This is the polynomial. Okay, so this polynomial has 3 roots. Okay, so this polynomial has 3 roots. So as you can see, f of 2 is 0, f of 4 is 0, and f of minus 1 is also 0. So from directly I can say that, so I have these 3 elements and all of them are certainly, all of them are distinct. Okay, and the image of all these 3 elements, they are same. Okay, so this is not allowed for 1 function. So that means this function can't be a 1 function. And again, like you can use so again, like if you see the graph, okay, so if you see the graph of this function, okay, so if you draw the graph of this particular function, and also you can so there also you can use this horizontal line test to tell that this function cannot be on, sorry, not onto, so cannot be 1 so if you see the, if you draw the graph, this is 2, this is 4, and this is minus 1, and so by computing the end behavior, if you see if x tends to infinity plus infinity, then f of x also tends to plus infinity, and then certainly you can say that this from the right it will come, the graph will come from the from the positive side of x-axis, so it will come like this, and since the multiplicity of 4 is odd, then it will cross the x-axis, and again it will come back to 2, and again it will cross this 2, and again it will come back to minus 1, and it will cross like this. And now if you apply the horizontal line test, so for example, if you take, maybe say if you take this line, okay, as you can see, this point x1 and this point x2, they have same image. Okay, and similarly if you draw this line, this horizontal line, you can see this point and this point, they have the same image. Okay, so I'm basically more or less saying the same thing. So again, like this is enough for you to tell that this function is not
Sir, can
one.
we say
Hmm.
can we say it has more than one root, so it is not a 1 function?
Correct. Yes, yes. That is what basically that is what we have used here, right? So
Yes.
in the first method, that basically, so it has more than one root, right? So more than one root means what? You have two. So more than one root means what? You have two things, two
That
distinct
is also a line
things,
test.
two distinct thing. Okay, and image of these two things are 0. Okay, so both image of both the things are basically 0. Okay, so that is the meaning of two distinct root, right? Or let's, yes.
Sir,
Hmm.
uh, sir, it might be a very small question, but it has taunting me. Sir, how did you find out the roots? Sir, earlier also I could not understand this. Can you please explain me?
No, so the thing is, okay, so as I said, so see, finding roots of a general polynomial, it's extremely difficult. Okay, so it's not possible if I give you some arbitrary polynomial, it's not easy to find out the roots. Okay,
No, no,
so
no. How did you
hmm.
find out x minus 2, x minus 4, and x plus 1? How did you
So
factorize these?
okay, you are saying how, so see, factorization is a different thing.
Okay.
So factor, okay. So let me tell you. Okay, so again, I guess this is more or less. So this is
Sir,
x
in this
cube.
case, we have done trial and error method.
Yeah, correct. So basically, so you have to start uh, with the trial and error method. Okay, 2x plus 8, right? So
Yes, sir.
you know how to find the roots of a degree 2 polynomial, right?
Okay. Yes, sir.
You know, right? So,
Yes, sir.
but now you have degree 3. So for degree 3,
Yes.
you have to start with trial and error method.
Okay.
First, take x equal to 0.
Okay.
What is f of 0?
8.
So certainly this is not a root, right?
You know. Yes, sir.
So now you start with x equal to 1. What is f of 1?
5.
Sorry?
So minus 2. So, sir, minus 4. 2 is 2.
What
10. 10.
whatever it is, 10,
Yes,
right?
sir.
This is
10.
not 0, right?
No, sir.
So that means 1 is also not a root. Now you take x equal to minus 1.
Okay. Minus 1 plus 4. 2. Minus.
This is a 0.
Yes, sir.
This is a 0. So that means you know that minus 1 is a root of this equation, right?
Okay. Oh, I got it, sir. Now, ultimate is we have to find the thing where it equals to 0, right?
So once you know for a degree 3 polynomial, once you know one root, then actually you don't have to go, you don't have to further, you don't have to do trial and error method. So now what you know x plus 1 is a factor of this polynomial, right?
Simply, I can divide this.
Yeah, so once you divide this, you can write f of x, right? X plus 1 times some times uh, times with a quadratic polynomial, right? Some quadratic polynomial, x square plus bx plus c.
Let's see.
So
Yes.
now you can apply the quadratic
Formula.
formula. Yeah, so this quadratic formula, there is a formula for to find out the
Minus b
roots
plus
of,
or minus root of
yeah,
b square plus
whatever.
4ac by
So,
2a.
yeah, correct. So
In
now,
HRM.
yeah, so now you can apply that to get the roots of this polynomial. So
Yes.
finally you have all the roots of this f of x. Okay.
Okay, sir. Thank you, sir.
I would like to add one more point in this, sir.
Yeah, just a minute. Yeah, just a minute. Just give me a minute. So certainly, but okay. So certainly you can't apply the same rule for degree 4 polynomial. Okay. So for degree 4 polynomial, once you know one root, then certainly you can't apply the same thing, because so somehow you have to know two roots. Okay. So then only you can write some x minus a and x minus b and times some quadratic equation.
Hmm.
Yeah, Ritik. Yeah.
Yes, sir. Got it, sir.
No, someone said he
Yeah,
wants.
sir, I would
Okay,
like to
not.
see.
Yeah.
In
Hmm.
this example, fortunately, we got from 0 we went to 1, then we went to minus 1, we got a root. In case, even if minus 1 was not satisfying, okay. So what I was thinking is, just when you are explaining only, we can put a graph and for x equal to 0, for x equal to 1 and x equal to minus 1, we have calculated. We can draw a smooth curve between that and we can see where it crosses x0. Approximate x coordinate we can come now, sir. So nearest to that we can approximate, trial and error method we can use.
Correct. So basically, in the trial and error method, so you know that's intermediate value theorem, right? I guess uh, in one of the week, Nilesh sir mentioned this in his lecture. So the thing is what actually. So if you take a value, let's say f of a. Suppose f of a is positive, okay, and f of b is negative, right? So if you see the, suppose this is A and this is B, right? And you know f of A is positive. So basically your graph will cross this x-axis. Okay, so graph will cross the x-axis in between A and B, because f of A is positive and f of B is negative. So the graph will cross this x-axis in between A and B. So that means you must have a root in between A and B. So that is also another way of finding the roots. So if you know that f of 5 is positive and f of minus 5 is negative, then certainly you can check all the numbers in between, let's say 5 to minus 5. Okay, certainly you can't check all the rational and irrational number. Certainly you can check all the integers, and you can check whether one of them is a zero of this equation.
And sir, in the junior classes, we had read also one thing that the in trial and error method, if we are finding the root, the root of the cubic polynomial would be the factor of the constant term. Will be in the factor of the constant term. Just like the factors of 8, we can write 0, 1, 2, and 4 and 8. So we can put just those values and their negatives in the cubic polynomial and check for the heat and trial method.
Yeah, so that is true when this this coefficient of x square xq is 1. Okay, when the coefficient of xq is 1,
Yes,
that
yes.
that whatever is saying, so that is basically called rational root theorem. Okay, so
if we can multiply the coefficient of x cube and the constant, can we get the factors in the same method as he mentioned?
sorry, I didn't get your question.
So if we multiply the coefficient of x cube and the constant and factorize that, can we get, can we get the roots while doing the trial and error method?
No,
As
no,
you
no.
mentioned.
No. There is a theorem that is called rational root theorem. So basically it says, as far as I remember. So suppose you have a polynomial. Suppose you have a polynomial p of x, which is x a, let's say axn, uh, an xn, an minus 1, x n minus 1. Okay, up to a0. Okay,
To the power of n0.
x to the power 0, which is basically 1. Okay, so if suppose let's say r by s, if r by s is a root of p of x, okay, so then probably, I'm not sure, then probably x r divide a naught and s divide a. Okay, so that is actually the rational root theorem. Okay, I'm not sure about this a naught or a n. Let me take an example, then probably I can say, let's say 2 3x square minus 2 No, this
So
is.
you can take the same example and do it, no, sir.
Sorry.
Same example only we can take.
Okay, so there is a problem. So the problem is actually this one. Okay, one divide everything. So it doesn't matter what you are taking. So let's say suppose you have a polynomial for, and the root of that polynomial is basically 2 by 3. Okay, so that means let's say you take this polynomial. That means x square equal to 4 by 9. Okay, so that means you have 9x square minus 4 equal to 0, right? So for this polynomial, 3 by 2 is a root, right? Sorry, 2 by 3 is a root. 2 by 3 is a root means 2 divide 4. So R divide, yeah, fine. So this is correct. R divide A naught. Okay, so if you see here, A naught is what? A naught is 4, right? And what is An? An is 9. So R by S is a root of this polynomial. So R divide A naught and S divide A. So this is actually your rational root theorem. Rational root theorem. So whatever someone just said, right? So if An is equal to 1, then basically the roots are, if it has a rational root, then it should divide this A naught. Okay, not rational if it has integer. So you can also apply this theorem to find out the roots of, to find out the integer roots of a polynomial. Okay, this is also a easier method to find out the roots of any integer roots of any polynomial. Okay. Or maybe, or at most rational root, but certainly you can't find out, you can't find the irrational root so easy. Okay. So for example, if you apply this thing here, then basically the possible roots are, the possible integer roots are precisely the divisor of 8. Okay, so it can be either plus or minus 8, plus or minus 4, plus or minus 2, or plus or minus 1. These are the possible roots, possible integer. So again, you have to check all this value to tell which of the following are the roots of this polynomial. Okay, so let me go solve some more problems. Okay, let me see. Is there any question related to 1, 1 and 1, 2? Okay, so let me take this question. So you have a bunch of statement, and you need to tell which of the following statement are correct, or yeah, which of the following statement are correct. So the first statement is this function, okay, 4x plus 3 is 1, 1. And obviously we are excluding, so we are excluding 5 minus 3. So this is basically, it's a function from r minus 5 by 3 to 1. Okay. So again, the second statement is the function f of x, which is equals to mx plus c, and where m is not equal to 0 is 1, 1. Okay, so the third option is a quadratic equation having two distinct roots is 1. And the last option is a quadratic equation having two equal roots is 1. Okay, so what about option number 1? What about option number 1? Whether this is a 1-1 function? Any idea?
This cannot be a one-one function. That is what I think, sir.
Why?
For any, for some x, we can always get denominator and numerator equal. So it becomes 1 by 1. So you can have one or more than one root for this.
No, this certainly this you can see, right? This is a deduced moral some sense. This is not a polynomial, so you can't talk about the roots. Okay, but you can only find one point. If you see this function, you can only find one point in the domain which maps to 0. Okay, so which maps to 0. If you take only probably minus 3 by 4, only this is the only number which maps to 0. So yeah, so you can't find any other points whose image is 0. This is the only point whose image is 0.
Sir, but function mx plus c is also 1 1 and
Yeah, I'll come to that. Okay, so
okay, okay.
let me complete the first option.
Because the image can have for various x, we'll have one particular image which is 1 when both numerator and denominator are equal.
Okay, so do you have any such x, is in your mind? Like, can you give me few examples, few values of x for which this is true? So basically, what you are saying, I can find some x1 and which is not equal to x2, but f of x1 and f of x2, they are basically 1. Okay, this is what you are saying.
By seeing, I'm just thinking, sir.
Yeah, got it. So okay, so the thing is, okay, I guess this is not one. This is 1-1 function. Okay, so for that probably I have to prove. I have to prove that this is 1-1 function again. Like I have to use the normal, like the method I already told you. So basically, what I'm going to do here, I'll show that if f of x is equals to f of y, okay, that means x equals to y. So if I can show this thing, that if f of x equal to f of y implies x equal to y, that means f of f is 1. Okay, so let me start. Suppose f of x equal to f of y. So what is f of x then? So f of x is 4x plus 3, 4x plus 3 divided by 3x minus 5, right? And this is 4y plus 3 divided by 3y minus 5. So now what you do, you multiply, you try to clear the denominator. Okay. If you clear the denominator, so basically what you will get, 4x plus 3 is 3y minus 5, which is same as 4y plus 3 times 3x minus 5, right? So now if you multiply, what will be the final result? So this is 4x plus 4x into 3y, 12xy, and this is 20x, correct? Yeah, this is
Plus
9y,
9y
yeah, minus 15,
15
right? And
equal to 12xy
12xy
minus 20y
minus 20y
plus 9x
plus 9x
minus 15.
minus 15, right? So now what we can do,
12xy cancels.
yeah, this and this, they get cancelled.
Minus 15 minus 15.
This and this get cancelled. So I'm left with so I'll plug all the terms together. So now what I'll have, this is if I take
20 times
no, okay, so this one I'm taking these two things into the left hand side. So then what I'll get, minus 20x
20y.
plus 29x, right? Then 9y plus 29y equal to 0, right?
Okay.
I'm not doing any mistake, right? Yeah, minus 29x minus 29. So I can multiply 1 by 29. So if I multiply 1 by 29, so what I'll get, minus x
Plus y.
equals 0. That means x equal to 1. So basically what basically we proved that if image of two elements, are same, so image of two elements, if x, I have y, and what if image of these two things are same, okay, image of these two things are same, then these two things are also same. Okay, so that means this function is f is 1 1, f is 1. So this function, whatever we have written here, this is a 1 1 function. Okay, is it clear?
Yes, sir.
Okay, so what about option number 2?
So that's a straight line.
One.
Yeah.
Mx plus c is a straight line, so which is obviously 1:1. I mean 1 in 1 1.
Yeah, so the most crucial thing here is m is not equal to 0. Okay, so if m is 0, then this will become a
It's a
constant
constant.
function. Yeah, and constant function is certainly not 1 1, right? So since m is not 0, okay, so that's why this represent a straight line. Okay, so this represent a non-horizontal straight line. Okay,
Actually,
so
it is a bijective function.
uh, so bijective function from R to R, right?
Yes.
Yeah, correct. So this is a bijective function, but yeah. So but now we are more concerned about one to oneness of this function. So as you can see, this, if you draw any straight line, you can easily see that this straight line is always a 1 1 function. So if I draw, let's say, this straight line, So if I draw this straight line, let's say, suppose this is my straight line, that means the slope is positive.
Yeah.
So this straight line, as you can see, if you apply horizontal test, any horizontal line can intersect this graph of this function at most one point. Okay, this is a point, at most one point. Can't touch the yeah, correct. So, and similarly, if you draw some line with negative slope, maybe, and in that case also, maybe say you take this line, negative slope. Okay. So negative. Okay, so it will something like this. Then also you can clearly say that if you apply the horizontal line test, and here also any horizontal line, it certainly it can't touch the graph of this straight line more than one point. Okay, so in certainly in both the cases, horizontal test tells you that a line, a straight line with positive slope is 1. Okay, so that this part is really crucial. See, m is not equal to 0. Okay, because if I take this straight line, okay, so for example, if I take this straight line is not 1. For example, this straight line, if I take this straight line, this is a straight line, right? This is a straight line, but this is not 1, okay, because at all the points the value are same. So in that case, this is not. So any straight line with let's say with non-zero slope, okay, that straight line is always positive. That straight line is always 1. So what about option 3? That I guess we have already proved it, that
Yes, sir.
we have quadratic equation with two distinct roots. Certainly it can't be 1. And what about option 4? A quadratic equation having two equal root is 1.
Sir, obviously, again, quadratic equation is not 1.
Correct. So
except at the root point, maybe it is only 1. Any other point of x, it always have to.
Yeah. So basically, we prove even something more. Basically, we proved that any quadratic equation can't be 1. Okay. It doesn't matter whether it has two real root, two equal root, or two complex root. It doesn't matter. So any quadratic function, okay, can't be 1, because if because from the graph, it's clear from the graph that if I draw a horizontal line, then I can find a horizontal line where the horizontal line cross the graph at 2 points. Okay. Let me check few more questions. Is there any question which you want me to discuss?
Sir, yes, sir. Even yesterday we were trying, but yesterday that was not possible because he was taking. See, previously we were telling, no, sir, f of x is equal to f of y, which means x is equal to y, then f of x equal to f of y. Then it is 1 to 1. But there was one question in activity, question number 4, activity 5.2 or 3. It says x is not equal to y, and f of x not equal to f of y. Then whether it is 1 to 1 or not. So if you take equal to, then if it is 1 to 1, then we thought if not equal to means 1
Okay,
to
so
1.
can you, okay, I just give me a minute. Okay, so question number 4. Okay, question number 4. Okay, let me discuss this question. Okay, this is question number 4. Okay, so just give me a minute. So yeah. Where is one towards some. Yeah, so this is the question, right? Is it my screen is visible or not?
Visible, sir. Visible, sir.
Yeah, so this is the question, right?
Yes.
Yeah, so okay, so the question is which of the following statement? Okay, so let me change the question. Which of the following statement are true? Okay, we need to find which of the following statement are true. So what about option 1?
Option 1 we just proved, sir. You just proved, no, sir. X1 equal to X2, then Y1 is equal to Y.
Yeah.
I mean X1.
Yeah, so this option 1 is certainly true, right? This is a true statement. If basically if f of x is equals to f of y, if this implies that x equal to y, okay, this means, so this is the another way of saying that two distinct input have distinct output. Okay, because it's saying if the output are same, then the input are same. Okay, this basically it's saying if the output are same, then the input are same. That means two distinct input will always have distinct output. Okay, so that means option 1 is correct. So one-to-one function are not always reversible on their range. Again, this is also incorrect, right? Because you can invert a one function on their range. Okay. So this is how the inverse of a function is defined. If a function fails the horizontal line test, then it is not reversible. What about this statement? Option 3, whether it is correct?
Sir, if it fails the horizontal test, then it is not a function at all, no, sir.
No, horizontal test means it's not a one function. See, vertical line test means if it fails the vertical line test, then it is not a function. If you try to recall the things, actually vertical line test means a single input has two different outputs. Okay, two
Sorry, correct, sir. Correct.
Yeah.
Sorry.
So yeah, certainly if a function is not one, okay, then certainly it can't be reversible, right?
Yeah.
So this is also correct. Next is saying a function is called one-to-one if f of x1 is not equal to f of x2, okay, then x1 is not equal to x2. What about the fourth option? Any idea?
It is just reverse of first option.
No. What do you mean by reverse of the first option? Okay, so
Reverse means first option is it is telling us function x of means is called 1, where function x equal to x2 is in relation with y, right?
No, sorry. Can you repeat? So first option is saying that if f of x, if the image of two elements are same, then the inputs are same, right?
Yes.
Sir, one correction.
Sorry.
One correction. The second option says it is false. If you are saying it true, one-to-one functions are not always reversible on the range.
Yeah, this statement is correct. Okay, so in portal actually it's say asking which of the following statement are false. Okay,
false. It says it is not false. Okay, then true means it is true. Tick. Then the first function it says is false.
Okay, my question is slightly different. Which of the following statement are true? Okay, that is my question. Okay. So the first Okay, let me see the answer, what you are saying, important. One-to-one function are not always which of the yeah. So this is certainly okay. I only made a mistake. So this is it's saying which of the following statement are false. Yeah. So I am asking which of the following statement are true. Okay. Yeah. This is certainly incorrect. Yeah. One to, so if you are taking a one-to-one function, then it is always reversible. Like this is how you define, because when you take one-to-one function, okay, so suppose you have a one-to-one function, suppose your domain a to range of a, okay, then this is basically, it's a bijective function, right? So from when you're, so in this case now your range and codomain, they are same. So this is a one function from a to range of a. Okay, so in that case this is both one and onto. Okay, so that's why it's always bijective. And since this is bijective, then you can always reverse the function. That means you can always find the inverse of the function. Okay, so this is incorrect. Yeah, thank you. Yeah, so let me come back to option four. So yeah, someone was saying something. Okay. Okay. So someone was saying something. Can you repeat it?
Sir, I was telling this,
Hmm.
if first option is correct, right? It is true, and it is 1, right? Because for the distinct value we are
If this if this hold, that means the function is 1. Yeah. Continue.
yes. If this is 1, then you can see the last option. It is just opposite of first option.
What do you mean by opposite? There is
Opposite means
Hmm.
opposite means for distinct value function is not equal to distinct value, right? Function x1 is not equal to function x2.
Hmm.
So this must be false, no?
No, this statement, I'm asking whether the fourth statement is true or false.
False.
Yeah, this is correct. This is certainly, this is not the definition of one function. So if you
Yes.
actually, if you see closely, actually this any function will satisfy this condition. If you pick any function, it will satisfy the condition. Okay.
Yes, sir.
See, it's saying that if the image of two elements, so you have two elements x1 and x2, it's saying that these two things are different. Okay, if these two things are different, then certainly these two things can't be same, because if x1 is equal to x2, then basically I have only x2, and image of x2 is f of x1, and image of x2 is f of x2. That is not allowed.
Yes, sir.
Yeah. So
Yes,
so
correct.
this condition holds for any function. Okay, it's not the definition of one function. You pick any function, this is true for any function. Okay, it's basically saying, so this condition is basically saying a single element cannot have two different output. Okay, that is what it's saying. A single element can't have two different output. Okay, so that means this condition is true for all the functions. Okay, is it clear?
No, sir, it says two different elements. No, sir, x1 and x2 are two different elements.
No. So it's what it's saying. You have to first read the first thing. Okay, what is the first thing? What is the first thing?
F1 is not equal to F2.
F of x1 is not equal to
F2, f of x2.
f of x2, then it's saying then x1 is not equal to x2, right?
Yes, sir.
So you take a function, right? Any function. You take any function f. Okay, you have x1 and x2 here, right? And you have f of x1 and f of x2 here, right? Suppose you know that f of x1 and f of x2 are not equal, right?
They're distinct.
Now
Yeah.
can you tell that x1 and x2 are equal? Is it possible? Is it possible that x1 can be equal to x2? Is it possible? If x1 is equals to x2, then basically I have only x1, right? Correct or no? So
Yes.
if I have only x1, then image of x1 is f of x1 and also image of x1 is f of x2. Because x1 is equals to x2, right?
Okay.
So in that case, image of x1 is f of x1 and also image of x1 is f of x2 because x1 is equals to x2, right? So then what I am getting? I am getting for a single element x1, I am getting two different image. That is not possible. Okay. So basically what I am saying, this condition is true for all the functions. If the image of two elements they are different, then both the inputs they have to be different, they can't be equal. If that means if they are equal, then for a single element x1, I am getting two different output, f of x1 and f of x2. This is not possible, okay, because it's already given that these two things are different, and for a single input I am getting two different out. That is not possible for.
Sir, one of the examples, the equation of a circle. In that, for one x1, you will have two f2s.
Yeah, circle is not a function, right?
That's what, it's not a function at all.
Yeah.
So this is not a function. This is not a function at all, first of all.
So what actually I am saying, if you pick any function, forget about 1, 1 or on, whether it's 1, 1, whether it's on 2, forget about everything. If you pick any function, then this condition is true for that function. Okay, that is what I wanted to, that is what I proved here. If I pick any function, then this is always true, always true. There is nothing special about 1, 1 function. Okay, this condition is true for all the functions. Okay, for example, if I take f of x equal to x square, okay, f of x equal to x square, this condition is true for this function, right? This condition is true for this function also, because if x1 square is not equal to x2 square, that means x1 is not equal to x2, right? Because if x1 is equals to x2, then x1 square is will be also equal to x2 square, right? So this is not, so there is so this condition holds for any function. Okay, there is nothing special about one or onto function. Okay, so this is not the condition for one function. This is a condition only for a function. It will satisfy for all the functions. Is it clear now?
So the
So
answer
could you
is true or
explain the
false?
option 2? That is
Yes, sir.
reversible.
Even I have a question in second and third option.
I'll come to that.
Understood the horizontal line test and vertical line test, but
What
couldn't
does
understand the
reversible
connection
mean,
between
sir?
reversible and horizontal line.
I'll come to that. But now I'm option number 2 and 3 I will come. But what about option number 4? Now is it clear what I was basically saying?
Yes, sir.
Yes, sir.
Yes, we
Yes, sir.
understood.
Okay, so what is the problem with okay? So what is the problem with option number 2? So
No problem, sir. We
Then
didn't
now
get the
the
word
option
term
number 4 is
reversible.
true or
What
false, sir?
reversible actually means.
So, okay, reversible means actually, so reversible means invertible. So, so, so this is basically Dean, yeah, Narendran.
Now the statement, fourth statement is true. Whether it's true or false, sir. Now the
This
fourth
is
option.
this like this fourth statement is false. This is
False.
Yeah.
Okay.
This is not the definition of a 1-1 function. This condition holds for any function. This is not a definition of 1-1 function, but this is a definition of 1-1 function. This is a definition of 1-1 function, but this is not a definition of 1. Okay. Okay, so you know invertible, or is there any confusion between invertible function and reversible function? Because reversible and invertible, they are basically the same thing.
Please, if you could.
So, sorry?
If you kindly explain
example.
invertible with some examples, yes, sir.
Yeah. So basically, what actually I want to say, so suppose you have a function, right? Suppose you have a function, let's say from A to B, and this function is 1-1 and as well as 1-2. Okay. So in this case, if A is a function from A to B, which is both 1-1 and onto, in that case, this function is reversible. So what is the meaning of reversible? That means I can find another function g. I can find another function g, which is basically from B to A, which is basically from B to A, and this g function is also both 1-1 and 1-2, such that if I compose these two functions, okay, if I compose these two functions, then this is basically the identity function. If I compose both f comma g and g comma f, then I should get the identity function. Okay. So when a function from A to B, so if a function from A to B is both 1-1 and onto, in that case, this function is reversible. And what is the meaning of reversible? Reversible means I can always, so if a function is both 1-1 and onto, I can always find a g. From the opposite direction, right? So if f is from A to B, okay, then I can find a function from B to A. I can find a function from B to A such that this composition, these two compositions, they are identity. Okay. So for example, so whether this definition is clear now, what is the meaning of reversible function? I'll come to example, but whether this definition is clear?
Yes, sir.
Yeah. So suppose you take this function. Okay. Suppose you take this function f of x equal to 4x plus 3 by 3x minus 5. 4x plus 3, suppose this function. 3 by 3x minus 5, right? So So certainly this function is not defined at x equal to 5 by 3, right? Because if I substitute x equal to 5 by 3, then I have something by 0, and certainly something by 0 is not a real number, so this function is not defined at this point. So suppose you take this function, okay, suppose this, and we have already proved that this function is 1, right? So if I consider this function from r minus 5 by 3 to the image of a, okay, image of a, that means the range of a, okay. So in this case, so my set, this B set is basically image of a, okay. So by definition this is both 1 1 and onto, correct, or because we have already proved 1 1, and by definition this is onto. This is 1 1 and onto or not? Is it clear why this is 1 1 and onto?
Yes, sir.
So this is 1 1 and onto. So basically, so in that case, if so, since this function is both 1 1 and onto, okay, in that case I can find a g. Find a g. So g is basically from the opposite direction. G is from B to A, B to A. So A, so here A is R minus 3 such that f x is identity as well as f compose is identity. So the next question is, so theoretically I know, okay, I can find a g which satisfy this condition. But the next question is how to find the formula for g precisely. Okay, so how we can get the formula for g more precisely. Okay. So we know that g satisfies. Yes.
Sir, the range of G should be R minus 3 pi by 3.
Okay, r minus 5 by 3. Okay, so I can find the range. Okay, so I don't have to do much.
No, you wrote 3.
Which one?
G is defined from B
Okay,
to
okay,
A.
sorry. Yeah, correct. You are correct. Okay, you are absolutely correct. So okay, so I don't have to find this image of f. Okay, I can find this set B once I know what is the expression for a g. So g is something which satisfy this condition. Okay, f compose g of x is x, right? So this I can write. Okay, I'm getting some noise. Okay, this I can write. Okay, just stop me when you have any problem. At that point, please stop me. Okay, so this is f of x equal to x. This is what I have written. So what is f of g of x? What is f of g of x? So my f is here. This is the expression for f of x. Then what will be the value of f of g of x? What will be the value of f of g of x? Can you tell me what will be the value of f of g of x?
At the place of X, we can put Gx.
Correct. So this means this is 4 times g of x plus 3 divided by 3 times g of x minus 5, which is 3. Clear? So instead of writing g of x, suppose we are denoting this g of x as y. Okay, g of x as y. And so basically what we want a expression for g of x. We want a expression for g of x, right? So for that, what we have to do? So we have to write y in terms of x. So if I can write y in terms of x, then I will get this y something in terms of x, then I can find a expression for g of x. Okay, so that is what I am going to do now. So this is, so if I write g of x equal to y, this will become 4y plus 3, then 3y minus 5 equal to 5. So my next target is I have to write y in terms of x. Now you multiply everything, you try to clear the denominator, what you will get? 4y plus 3 is equal to x 3xy minus 5x. Okay, so now what you do? So we want to write y in terms of x. So what we will do now? 4y minus 3xy is basically minus 5x minus 3, correct? So if I take y common here, what I will get? 4 minus 3x is minus 5x minus 3, and this is nothing but y equal to minus 5x minus 3 by 4 minus 3x, right? And this, I guess I can write, if I take minus common, then I can write 5x plus 3 divided by 3x minus 4. And this is y. So finally what we have? Y equal to 5x plus 3 and 3x minus 4. And what is y? Y is basically, precisely, y is g of x. So g of x is 5x plus 3 divided by 3x minus 4. So this g of x, whatever we wanted to find, this is basically x goes to 5x plus 3, 5x plus 3 by 3x minus 4. So now I can easily find this set B. I can easily find this set B, because B is basically the domain of this function, right? So as you can see, if I take x equal to 4 by 3, then only this point can't be inside the domain of G. So this B is nothing but, this set B is nothing but R minus 4 by 3. And also once we know B, and also this image of F is nothing but this set B, R minus 4 by 3. Okay, so this, for this function F, this G is the inverse. And also you can check that. So what basically we have computed G of x, okay, using this relation, F compose G is x. But again you need to check, you have to check that this G of x also should satisfy this condition also, and you can check that this G of x will satisfy this condition. G compose of x is precisely x. That you can check. You check that this G will satisfy the second condition also, because we have computed G just by using the first condition. And also we should check that whether this G also satisfy this condition or not. Okay, this G will satisfy this condition, then this G is a inverse of F. And you can check that this G will satisfy the second condition. Is it clear?
Yes, sir.
Yes, sir.
Yeah. So in invertible function is basically it's a function which is both 1 1 and 1 2. So, but okay, finding this you know that suppose you know if is both 1 1 and 1 2, but finding the inverse. Okay, finding the inverse. Okay, in generally you don't write G. In generally you don't write this as G, but instead of G you write it as a power minus 1. Okay, so instead of, so here we have written G, but in generally you write this G as F inverse. Okay. This is basically the inverse of. But again, so find the complete representation of F inverse, that part is slightly tricky. Okay, is there any other doubt? Or maybe some other questions you want me to discuss?
No, sir.
Okay. Okay, let me check whether I have 20 minutes. I can solve some questions. 5.2.
Sir,
Yes.
I have a doubt in activity 5.7, last question number 5.
5.7. Last question. 5.7. Question number 5, right?
Yes, sir. How to identify whether which function is greater than or less than if
No,
the
you don't have
values
to
of.
you don't have to find the it's basically it's saying to find out at a particular point, right? Okay, just give me a minute. Let me.
No, sir, at arbitrary point, how can we find?
No, arbitrary point.
Uh,
Certainly.
Option number third and option number fourth.
Okay. Just give me a minute. Let me take the snapshot and let me solve it. For that, you have to find the composite function. Then only probably you can. Question number 5. Okay, so this question, right?
Yes, sir.
Yeah. So what is f of compose g of x? So you have doubt in these two options, right?
Yes, sir.
Yeah. So what is f compose g of x?
But it is coming out to be 2 under root of 8x square plus 9.
Okay. Let me check. So what is g of x? G of x is 8x square, right? Correct.
Yes, sir.
Then this is 2 times square plus 9, correct?
No, sir. You squared it once more.
Okay, so this is only x plus 9. Sorry. So this is 8x square plus 9. Correct, right? X
Yes,
plus,
sir.
yeah. So this is your f of this part, f compose g of x. Okay. So next g compose f of x. So what is g of g compose f of x? So this is g of 2 times x plus 9. So this means
8 times and square of
this
the.
is 8 times 4 times x plus 9, right?
Yes, sir.
Correct or not? So this is what 32x
Plus 32 into 9.
32x plus 9, right?
No, sir.
No.
32 times 9.
Yeah. 32 times 9. Okay. So the thing is, what actually you have to do, you have to use this thing. So you know, right? If a is greater than b, right? That means a square is also greater than b square. Correct or not?
Yes, sir.
So then basically you have to use this method. Okay. So certainly you can't compare now. Okay. But if you square it, then certainly you can, right? If f compose g of x is less than g compose x, that means this should also hold, right? This square should also less than this square, right?
Yes, sir.
Now that means what? 4 times 8 x square plus 9 should be greater than what? Should be greater than
32x plus 32 into 9 whole square.
32 square times x plus 9 whole square. Okay. Now you try to find whether this equality is true or not. Okay, you have to basically you have to multiply and then you have to subtract. Okay, if you subtract this one, this is, let's say, a, and this, let's say, b. If a minus b is greater than 0, then certainly this condition is okay. If a minus b is not is less than 0, then certainly this condition is not. Is it clear now how you should?
Yes, sir. It is
Yeah,
clear.
fine. Any other thing you want me to discuss? Okay, let me check.
We have revisions, sir, for one
Yeah,
topic.
yeah. For quiz, right?
It's a quiz.
Yeah, definitely. You will have 2 revision session. Okay. Probably.
One more general question.
Mhm.
Sir, can we get the previous quiz or previous qualifier questions full paper?
I guess there are so many like your
No,
certainly we
not
do.
only one question, two questions, sir, full paper. So that how much time we are able to take to complete one paper?
That I understand, but I guess many of your senior actually they created some site and they kept everything there. Okay, I don't remember the site, but I guess you can get it. Okay, so if you are in some WhatsApp group or somewhere else you can ask it. Okay, or maybe you can ask in the discourse. Okay, if you are in discourse, then as far as I remember, I have seen a lot of thread regarding this, and I'm sure that many of the senior member, they actually created some site and they kept all previous year question paper in that site.
How can we approach them, sir? Like, we don't.
I guess you ask one question in discourse, like so you don't have to ask actually. As far as I remember, I have seen this kind of post in discourse. Okay.
So discourse means forum. You mean forum, no, sir?
Where is it, sir? Discuss.
Okay, so are you qualified student? Okay, so for qualified student, okay, so just remind me. Okay, I'll try to get the link of that site and I will share with you. Okay, just later just remind me.
Sir, I have posted a link.
Okay,
Thank you.
so someone already posted. So probably you can get in this. Is there any other questions? Okay, so then probably I'll stop the session now. Okay. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you very much, sir. Thank you.
Thanks.
Thank you, sir.
Have a good day. Bye.
Thank
you, sir.
Yes, please. Any doubt? Okay. Okay, bye.
Thank you.
Thank you, sir.
प्रणतं सुरेशं गगनसदृशं मेघं